Okay, domain of composed functions. Now, domain of composition does one kind of weird thing. So let's start with this first example, and I'll show you what I mean. So we're just going to start by finding f of g of x. That's what I want to find. So that is my step 1. Find f of g of x. So just like we were just doing, f is my outer, so that's what I start with my big fat parentheses, wherever there's an x. So there's an x. And g is what gets plugged inside. So g is my 4 over 3x minus 2. Now we will want to simplify this because this is a fraction in a fraction. So same thing we did last video. I'm going to times this 1 by 3x minus 2 over 3x minus 2. So then I've got a common denominator happening here. So now I'm going to distribute this negative 1 in. So that's minus 3x plus 2 all over my common denominator. Bring it up here. I'm going to simplify everything I can. So this is a negative 3x plus 6 over 3x minus 2. Now that it's all simplified, we can do keep, switch, flip. So keep the numerator, switch to multiplying, flip the denominator. And now I can distribute that 5 in to get 15x minus 10 all over negative 3x plus 6. So there is my f of g of x. That's my function. But that's not really what it's asking for. It's not asking for what f of g is. It's asking for the domain of f of g. So here's the tricky part. Anytime we talk about domain of composed functions, we can't just look at the domain of the answer. We also need to look at the domain of what I plugged in. Because if I can't plug it into here, then I definitely can't plug it into the final answer. So we need to look at two things. First, I need to do the domain of the inner function, which in this case is g of x. Then I need to look at the domain of the final function, which is my f of g of x. So let's list both these things. G of x is 4 over 3x minus 2. So when I'm thinking domain, I think roots and denominators. No roots here, I just have the denominator. So I say this denominator cannot equal 0. So I know that my denominator is everything except 2/3. That's my inner domain. Now I look at my final answer. That's the one we just got. Now for this final answer, same thing, roots and denominators. No roots here. So I take my denominator and say, that can't equal 0. Solve. And I get x cannot be 2. So that's the denominator of my final. So if not the denominator, the domain. So if I want the domain of the whole thing, I need to combine the domain of the inner and the domain of the final. So basically we're saying x can be anything except 2/3 or 2. So when I write that domain out, x can be anything except 2/3 and 2. And there's my domain. So just make sure you look at the domain of the inner and of the final. So I'm going to have you start example 8 on your own. First off, I want you to find g of f of x by yourself. Then come back and we'll find the domain of the inner and the domain of the final together. and put the domains together. So you're right now just finding g of f of x, and then you'll come back and check to see how you did. If you got a square root inside of a square root, you did it right. It looks really weird, but there's our g of f of x. So now let's start our domain. Look at the inner function first. My inner function is f of x. So that's square root of 3 minus x. Let's find the domain of that one. We know with roots, we set the inside to be greater than or equal to 0, because the inside must be positive. So minus 3. So x, forgot that when I divide by a negative, flip signs, x must be less than or equal to 3. That is my inner domain. Now I'm going to look at my final. And same thing, I still need to set the inside to be greater than or equal to 0. So I start to solve this, and hopefully right away you will notice that this function, this right here, will actually always be true, because a square root is always going to be greater than a negative number. Square root's never going to give you a negative number. That's not how it works. We can't square root negatives. So we know that this will always be greater than negative 2. So this domain is just negative infinity to infinity, always works. So our final domain is this one. Because when we combine these two together, this is the smaller one. So our final domain is from negative infinity up to 3. Everything less than or equal to 3. So that is domain of composite functions. In the next section, we're going to talk about plugging numbers into function composition and how to do that.